Hello everyone, welcome back to another physics video. I hope you all enjoy.
Okay, so we have a question here. It says if there's a 30-degree incline, so incline of 30 degrees, and it's a right angle, and there's a projectile off of that launching at 15 degrees, and it lands on a certain random point on the incline, then what is the horizontal distance, the vertical distance, and the distance in general? Assuming that the initial velocity of this projectile is 10 meters per second. Give a go at this question and see if you can figure it out. Okay, so I've assumed you've tried the question by pausing the video. Now let's see how we would approach this question. What I first want to do is that since there's like two angles, I want to make some values for theta. So I want there to be a theta, I want there to be a theta 1, and I want there to be a theta 2. I want theta to equal to theta 1 plus theta 2, which are both of these angles. So I want theta to equal to 45 degrees. And I'll assign theta 1 to the 30-degree angle and theta 2 to the 15-degree angle. So theta 1 is going to be 30 degrees. And theta 2 is going to be 15 degrees. And the reason why I want to do this is because I want to have a relationship between the x and y components of the velocity variables, the initial velocity variables, and the displacement variables, or the distance variables, in this case. So let's do that. So I want to first determine what my v initial x is going to be. So we know that v initial x is equal to v final x, because there's no acceleration in the x direction. Thus, we could say that our v initial x, and we're going to break down the components of the v initial, so it's going to be 10 times cosine of 45 degrees, because this is v initial, and this is our total theta, or just our theta. And the reason why I'm using theta and not theta 1 or theta 2 is because for velocity, we have to account for both of the angles. We can't just ignore one. But for something like distance, we only have to take account of the angle of the inclined plane, which we'll see after this velocity determination. So with that said, all we have to determine is this to find this. Now, what's a cosine of 45 degrees? Well, I could just use a calculator, but ideally, I want to figure out cosine of 45 degrees on my own using a 45-45-90 triangle. Now, a 45-45-90 triangle is a triangle that you should memorize, and it has an angle of 90 degrees and an angle of 45 degrees for the other two angles, and it's a right angle triangle. So the hypotenuse for a 45-90 degree triangle is radical 2, and this actually resembles radical 2x. Over here, it would be radical 1, or just 1. So just be 1, resembling 1x, which would just be x. And this would resemble x as well. So for our purposes, for this question like this, all we say is radical 2. So right here, all we would say, or all we would put down is radical 2. For here, all we would put down is 1. And same story for this adjacent side. Assuming that this is our main angle. This one right here. So with that said, the adjacent over the hypotenuse would be 1 over radical 2. So this would simply equate to v initial x is equal to 10 over radical 2 meters per second. With that said, we could also times the top and the bottom by radical 2. Now what would happen if we would do this? Well, if we would do this, then it would be 10 radical 2 over 2, which would simplify to 5 radical 2. Thus, v initial x would be 5 radical 2 meters per second. So let's write that in a corner somewhere. I'm going to write that right here at the end of my whiteboard. So v initial x is equal to 5 radical 2
meters per second.
Now for v initial y. For v initial y, that's going to equal to v initial sine of theta. And sine of theta is going to be sine of 45 degrees, which if you use a 45, 45, 90 triangle, you'll realize that it'll be 1 over radical 2. So this will be 10 times 1 over radical 2, which will actually be the same thing as 5 over radical 2. So this is going to be 5 times radical 2. So 5 times radical 2 meters per second. So this right here. So now I could write this in another corner beside where I wrote this. So v initial y is also equal to 5 radical 2 meters per second. Just like that. Okay, now what's our other components that we know of in terms of theta? Well, another component that we know of in terms of theta is our distance or our displacement. So we know that the angle of the incline is 30 degrees. So that's what we know about it. And that's enough, because all we have to do is we have to find some sort of relationship between the sx and the sy. And the relationship between these two sides is simply going to be the tangent of the incline theta. Tangent of 30 degrees is equal to sy divided by sx. And to make it simpler, we could just say sx times the tangent of 30 degrees is going to equal to sy. Now we could simplify this or expand this even more by saying sx is equal to vx times t, or v initial x times time times tangent of 30 degrees is equal to this right here. So let's do that. So let's erase all of this. And we know our v initial x is 5 radical 2, so we could say 5 radical 2 t times tangent of 30 degrees is equal to sy. Now what I see right here is that I see that the time is not solved for. Now since the time isn't solved for, what I want to do is that I want to use a formula like sy is equal to v initial y times t minus 4.9 t squared. In this case, this being 1/2 ay, which we already know is negative 4.9 in this case. So I want to use a formula like this. And we know that we could easily solve for this if we have our time, but we don't. That's the problem. So I want to make it in terms of time. So we have time is equal to whatever it's equal to. And then we substitute it in for the t here. So let's do that. So what I could say, and what I'm going to say, is that the time is equal to sy divided by 5 radical 2 times the tangent of 30 degrees. So this is what our time will be equal to. And based on that, I could just plug this time. So if we plug in for t, this is what we get. And we could plug in for v initial y as well, since we already have that. We know that's going to be 5 radical 2 meters per second, but it's going to be 5 radical 2 in terms of magnitude. And we could cancel these two out. So I'm just going to use a different color for this. Cancel these two out. And we're left with sy over tangent of 30 degrees minus this. Now we're left with this. So I actually want to determine tangent of 30 degrees as a fraction to figure out this part of the equation. So we know that the tangent of any given angle, like theta, is equal to the sine of theta over cosine of theta. So with that, we could apply the same logic to figure out the tangent of 30 degrees. We know that for the tangent of 30 degrees, it's going to equal to 1/2 divided by radical 3 over 2. And the reason I know this is because this is all we're saying is the same thing as sine of 30 degrees, which is 1/2 over cosine of 30 degrees, which is radical 3 over 2. If you were to calculate this would be the same thing as 1/2 times 2 over radical 3, which is 1 over radical 3. So that is the tangent of 30 degrees. Now we are left with this. So for this right here, this is the same thing as saying radical 3 times sy. So you can substitute that for this. Now that we have done that, we realize that for this right here, for sy, this is the same thing as saying 1 sy. So we can in fact move this sy and combine it with this because they are both like terms. Since we're moving it to the other side, this will be the same thing as saying radical 3 minus 1 times sy. Now we're going to determine radical 3 minus 1 in our calculators. So if you have a calculator like this one, this is how you want to do this operation. So you want to turn on your calculator, and this is TI-84 Plus. If you're interested in this model, you could buy it somewhere like Staples. So you want to click on second, and you want to click on this x squared button, because as you see, it shows the square root as well above it. So you want to say square root of 3. You want to find the answer to that, and you want to subtract it by 1. And that's going to be your answer. So we're going to replace this right here with that answer, which is going to be 0.732. So we have all of this is equal to 0. Now we want to try solving for this part of the equation right here. And we could do that with our calculators for the most part. So we want to say is that since we have negative 4.9, we want to divide negative 4.9 by this right here. So we're going to say 5 times radical 2, which is going to equal to this, and we're going to times that by the tangent of 30 degrees. I want to make sure that if we click on mode, we want to make sure that our degrees is selected by going on degrees and hitting enter. And then you want to click second, and then you want to click quit. And just like that, it's in degree mode, and then we're going to times it by the tangent of 30 degrees, which is going to give us this answer, and we want to put that to the power of 2, which is going to be 16.6 repeated. And if we grab negative 4.9, and we have to type this for negative sign. So if you have negative 4.9, and we're going to divide that by that answer by clicking on second, and then this negative sign, or answer, then we hit enter, and we get this for that answer. And so, this is what we're going to do. We're going to erase this right here. This is just going to be the same thing as saying negative 0.294 sy squared. Now this equation right here basically gives us the answer. So we could factor this by sy. So basically dividing both sides by sy. And the way we would do this is that we would times this by sy right here by removing another sy. So we'd remove this sy, and we'd make this into a regular sy. And then we do this on the other side as well. So basically, we just take away a sy from this, but we'd have to times it by sy. Now we notice that for here, this equates to 0. We divide both sides by sy, we'll get 0 divided by sy, which is equal to 0 again. So basically, we're just left with this when it's all said and done. So 0.732 minus 0.294 sy is equal to 0. We can move this to the other side, transpose it. So that will be negative 0.732 is equal to 0.294 times negative 1 sy. Now let's calculate this in our calculators by dividing this by this, leaving sy alone. So let's do that on our calculators. So we get 0.732. Let me zoom this in a bit. So 0.732 divided by 0.294, because the negatives cancel out. And we get 2.4897 as our displacement or distance in the y direction. If it was displacement, it would be upwards. So we get 2.4897 meters as our vertical distance. Now that we have sy, it makes our lives a lot easier because now we can easily solve for sx simply by dividing sy by the tangent of 30 degrees, because that's our relationship as we can recall from previously in this video. So let's do that. So we have this as our sy right here, and we're going to divide that by the tangent of 30 degrees. And this is going to be 4.31, which is going to be our horizontal distance. So just to recall, we have approximately 2.5 as our vertical distance and approximately 4.3 as our horizontal distance. Now, how do you think we could find the actual distance? Think about it for a second and return back to the video. Now, if you said we should use the Pythagorean theorem, you would have been correct. So let's actually use the Pythagorean theorem. So we would get our distance is equal to the square root of the following: sx squared plus sy squared. And let's type that into our calculator. So let's calculate that. So we have 2.5 squared. And we're going to add that by 4.3 squared. And we're going to take the square root of that answer. And our answer is going to be approximately 5 meters. So there you have it. Those are our answers. Sx is equal to 4.3 meters. Sy is equal to 2.5. And our S is equal to 5 meters. So these are our answers. Hope you all enjoyed this video. And as always, have a nice day. Like and subscribe. Bye.